So I'm going to be going over question 1. So for question 1, we're going to be looking at Quicksort. You can partially sort an array of numbers. So let's say we have an array of 7, 1, 5, 6, and 4. And let's also keep note of the index. So what Quicksort algorithm does is it picks a pivot and it's going to sort it so that all the numbers left of the pivot is less than the pivot. And all the numbers to the right are greater than the pivot. And it's going to keep doing this until the entire array is sorted. So you can choose any pivot, and different algorithms will have different ways of choosing the pivot. Sometimes it's the middle one, but in this one, I'm going to choose the last index to be the pivot. So let's say we choose 4 to be our pivot, and now we're going to go through each one and say, should it be to the left or the right? So we start with 7, that would be to the left. 1 would be, oh, I'm sorry, not to the left. So 7 is greater than 4, so it would be to the right. 1 is less than 4, so it would be to the left. 3 is less than 4, so it would be to the left. 2 is less than 4, it would be to the left. And 5 and 6 would be to the right. So now when we rewrite our array, we would have the left value, so we'd have 1, 3, 2, our 4, and then all the numbers to the right of the 4 would be 7, 5, and 6. So now we have our next part of the array. And now what we can do is do the same thing again. So here we have the left side of our array, and we have the right side of our array, based on where our pivot was before. So before we picked the end of the array, now our pivot will become the end of our subarray. So it's gonna be the end of the left side. So we're gonna pick 2 to be our pivot, and now we're gonna just rearrange the left side. So if we rearrange the left side, we're gonna have the 1 would be to the left of the 2, and the 3 would be to the right of the 2. So now we have 1, 2, 3, 4, 7, 5, 6. So now we did the left side of the array. Now we're going to look at the right side of the array and pick this as our pivot point, the 6. And we're going to repeat the same thing again, where we're going to sort the right side of the array, and all the values left of 6 will be less than 6, and all the values to the right of 6 will be greater than 6. So if we rearrange this, we already rewrote our first part. And the 7, 5, 6, we would have 5 would be before the 6, and then our 6, and then 7. So now the array is fully sorted. And this would have, let me rewrite the indexes in it. So these would be the indexes of the values in the array. So in the problem we have I, J, and K. So I'm going to say I means the index where we should be. and j is the actual index. And then we have a constant, k, which can be any value that's less than n. So n is the size of the array. So the size of this array is 7. So our k would have to be less than 7, or equal to 7, I guess. So indexing could be a little annoying, but let's say that when we're referring to I, which is the ith smallest number according to the problem, let's say that the 0th index means the 0th smallest number. The first index means the first smallest number. The second index means the second smallest number. So when I'm saying the ith smallest number, I'm starting with 0th as the smallest, just so that the indexing is the same and it's easy to go between j, where we're talking about indexes, and I, when we're talking about the smallest numbers. So let's say in our scenario that k is equal to 2. And let's say that I is equal to the 6th smallest number. So if we look at this, the 6th smallest number in the sorted version of this array would be 7. So if we decided to use quicksort algorithm and we started with this, when should we stop? So let's see right here. So I is the 6 is I is the 7 is the 6th is in the 6th smallest number position. So that means we're 6. The index of 6 is what I is. And j is the actual index. So if we look at this first part right here, 7 is actually in the 0 index. So if we did 6 minus 0, that would equal 6, which is not less than or equal to 2. So we want to stop when where I is and where j is 2 apart or less. So that's when we can stop sorting. So in the original array, we have to keep sorting. So now we did one step of our quicksort. We're doing our quicksort algorithm. And now we look, where is our 7? Our 7 is in the 4th index. And the actual index that 7 should be is in 6. So if we do 6 minus 4, we'll see that's equal to 2. And 2 is less than or equal to 2. So this passes, and we can stop sorting here. So this is how you're getting an array that's partially sorted using quicksort, because you can stop when where the number should be and where it actually is only 2 or less indexes apart. So in this part right here, the 7 was at index 4, and the actual place it should be is index 6. So the 6 minus 4 is 2, which is less than or equal to 2, which was our value of k. And that's it.